All right. So welcome everybody to today's CE Swiss Impulse session. My name is Oliver Wertschinger. I'm the President and Managing Director of the Chamber of Commerce, Switzerland, Central Europe. And I heartily welcome you to today's session about a very important topic that I was always very keen to learn more about. We have had sessions about the future of mobility before in terms of autonomous driving, etc. But one fundamental question to me was always, how are we going to power these vehicles in the future and be able to sustain our need for mobility? And so I'm very happy that today Christian Bach will tell us a little bit more about this. Now, before we start, I would love to just say a couple of words as usual. So I will share my screen with you. And all right, that should be it. First of all, as usual, I would like to thank all our partners of this Impulse sessions, which we've started in 2021, really with the idea of creating some kind of a TEDx talk for Central Eastern Europe and Switzerland, where we're going to cover topics that are relevant to us and that should inspire us. And we do this together with those 13 partner organizations across the whole Central Eastern European region. These are all chambers of commerces and business clubs that are focusing on improving the relationships between Switzerland and their respective countries. And again, they partner up with us in this Impulse session. So thanks a lot to all those chambers. Today, a couple of key points. You are all on mute. You don't have video, unfortunately. If you have a question for Mr. Bach, please use the Q&A button. Maybe you can also use the comment box and say hi to everybody and let us know where you are all from. You will receive the slides and the contact details and everything in a follow-up email. And you will be able to rewatch the session on our YouTube channel, which we will also send to you after this Impulse session. Now, the next webinar will be a different topic, and we have a working title for this, which is the regional impact of the war in the Ukraine on Central Eastern Europe. It will be by Marcel Hirziger from the University of Applied Science in northwestern Switzerland. And of course, also a very important topic 4 years into the war, and where we do see certain changes in the Central Eastern European region. And we wanted to have a specialist have a little bit in-depth look at this on a bit more, not a more important, but a serious topic. And I'm also looking forward to this one. Right. So now I would love to introduce Christian Bach. Christian Bach completed his training as an automotive engineer at the Bern University of Applied Science in Biel in 1987, followed by 2 training programs in the USA. Since 2001 already, 25 years, he's been heading MPAS, Chemical Energy Carriers and Vehicle Systems Laboratory, which comprises 6 research groups, and he is also responsible for MPAS Future Mobility Demonstrator. He also coordinates the Swiss consortium refuel.ch, which investigates the supply of sustainable fuels in Switzerland. He's a member of the Swiss Academy of Engineering Science and a lecturer at the Lucerne University of Applied Science. So, Christian Bach, the floor is yours. Many thanks for being here.
Thank you very much. I just share my slides. So I hope you can see now my slides. I'm very glad to share our vision about post-fossil mobility against the background of a changing energy system. Maybe for your information, EMPA is a Swiss national research lab within the ETH domain. Within the ETH domain, we have ETH Zurich and ETH in Lausanne as technical universities and 4 research institutions. And the EMPA is responsible for material science and technology research. We have roughly 30 labs, and one of the labs at EMPA is the Chemical Energy Carrier and Vehicle Systems lab, and we are working very much on this post-fossil mobility. My main target is to show that not only the change of a powertrain is leading to a decarbonization, but mobility and the change of powertrains can strengthen the decarbonization of countries and energy sectors. First, I would like to show what we are doing here at EMPA in the energy sector. We are mainly working on technologies, but they are always linked with energy, and I will focus on energy. One aspect is sustainable fuels. So we are investigating how, for example, hydrogen and carbon dioxide can be converted into synthetic methane or into synthetic methanol, and how these short-chained molecules can be converted to long-chained molecules, for example, as aviation fuel, as diesel, whatever. Another aspect is electric mobility. So we are investigating, for example, how storage can impact the decarbonization in mobility for electric cars, or how electric cars itself can provide the storage. I will come to this later on. And we are also investigating how possibly dynamic charging could impact electric mobility in future. At the moment, this is, of course, stationary inductive charging. So you maybe know this from your mobile phone charging. You don't have always to connect it by a wire, but it's also possible by inductive charging, and the same is true for mobility. And on a long term, it's also maybe possible to charge cars during driving. This could lead to especially for cars with small batteries, also to the possibility to drive long distance if the charging is possible during the driving. And the third part in this future mobility demonstration we are working are sensors for autonomous driving. We are working on modeling sensors, and we have a test track where tests can be done under different meteorologic conditions. So in winter, in summer, during the day, during night, we are able to emulate or simulate different conditions. Yes. So these are, I would say, the main mega trends in mobility, decarbonization and automation. And some of them are linked, some of them are separated. Mobility is a huge range. So it's not only private cars, but also goods transport, heavy trucks, off-road vehicles, airplanes, ships, and so on. And not all the approaches fits for all in the same way. Now, the very general target is clear. So it's net zero CO2 emissions by 2050. This was decided by the Federal Council in Switzerland in 19 and confirmed by votes several times. And on a first track, this looks quite clear, but at the end, it's not so clear. So what is the difference between net zero and zero? very often is not so clear, and what means this by 2050. And I would like to, let's say, separate this into three regions. One is clear. We have to change from fossil to renewable energy. That's one very important topic. If it is not possible to completely switch from fossil to renewable, it will become very hard to achieve this target. So this is, I would say, the number one topic, and very many activities are already ongoing to achieve this target. But this will not lead directly to net zero, because we have unavoidable emissions. And to achieve net zero, we have also to compensate for this unavoidable emissions, and this is done by negative CO2 emissions. This means we need also technologies removing CO2 from the atmosphere. That's the second part. So in Switzerland, we have 40 million tons of avoidable emissions if they are removed or replaced by renewable energy, if the fossil energies are replaced by renewable energy. And we have roughly 10 million tons, so a quarter of the avoidable emissions as non-avoidable emissions, which has to be compensated by negative CO2 emissions. So that's quite a large amount, and here technologies are not so clear. There are several technologies on the table, but they are expensive, infrastructure is not available, and so on. But this becomes a very important topic, we are sure. And one of the main topics, I would say, in this slide is the second line. All these technologies has to be implemented by 2050, which is in 25 years, fully covering all markets and so on, and this is extremely challenging. So this means we have maybe two phases. One phase is until 2050, where existing technologies, existing infrastructures, existing trade mechanisms play an important role. For example, airplanes on an international level will still fly with kerosene. That's no doubt that this will change by 2050. On a longer term, by 2100, by 2200, maybe this change. Maybe we will see hydrogen as hydrogen planes. That's possible, but not 2050. So this means to achieve this target by 2050, existing infrastructure, regulations, and also hardware plays a role. And I will focus now of this time frame by 2050. As mentioned, one main topic is the replacement of fossil energy by renewable energy. And the main question is, where does the renewable energy comes from? And to make it, let's say, simple in a first glance, we can say this energy comes from domestic or foreign sources. There are no other options. And in Switzerland, for example, the domain renewable energy is mainly renewable electric energy. Of course, we have also some potential for chemical energy carriers like biogas or wood, but this is very limited. So from a domestic point of view, renewable electricity plays a main role. And that's also the reason why electrification is important. So we should investigate where electrification could be done, because then we have the possibility to use domestic renewable energy. On the other side, it's also clear that it is not possible for Switzerland to be supplied by only own sources. So we have to import energy from abroad. And import means is necessary when we have not enough own renewable electricity. And this is especially the case during winter. But in winter, also our neighboring countries maybe lacks on renewable electricity. That's why we also have to consider to import renewable energy from long distance places. So that's why I expect that the main renewable energy import is in form of chemicals, because this is very cheap and easy to transport over long distances. This is what we do with fossil energy since long, and the infrastructure are available, the trade mechanisms are available. Of course, this energy carrier has to be produced before they can be transported. So, and if now we start with this domestic part, electricity plays a major role. So we have to first have a look on the electricity supply system in Switzerland. And this is clear, this may look, or this will look differently in your countries, in the Central and East Europe countries. I show here the situation in Switzerland. And in this diagram, this is from 2010, where electric mobility and heat pumps played a low role. So we see here a diagram over the year from January to December, and all points below zero shows where Switzerland was importing energy. So this mainly in winter, because we are not producing, we're not able to produce enough electricity within Switzerland. And during the summer, we see the points above the zero line. This is the phase where Switzerland exported energy. And in this specific year, so we exported 4.3 terawatt hours of electric energy to neighboring countries and imported 6 terawatt hours from neighboring countries during winter. So we had a difference of 2 terawatt hours, and this was somehow a standard case in this time. Sometimes 2 terawatt hour more export, sometimes 2 terawatt hours more import. And then it was decided to replace nuclear power by photovoltaics. And if we take an annual balance, this looks similar or easy. So we replace 25 terawatt hours of nuclear power by 25 terawatt hours of photovoltaics. But the production profile is very different. It is shown here in this green line or curve. And we see now we have the potential to export 14 terawatt hours, so 10 terawatt hours more than before. And it seems that we have to import 10 terawatt hours more than before with this new power generation regime. This is a scenario for 2050 when 25 terawatt hour of PV is installed and all nuclear power is phased out. Yes, one could say now, okay, the difference is still 2 terawatt hours, so the problem is the same, but that's not. So this means the 14 terawatt hours in summer is maybe not easy to export because our neighboring countries are also installing a lot of photovoltaics and they have excess electricity during summer at the same time. So if this electricity during summer is not consumable within Switzerland and cannot be exported, there's no business case for this photovoltaic system, and then it would most probably not installed. On the other side, during winter, we already now have problems or discussions supplying enough electricity during winter, and this will increase the problems. So that means we have to find solutions to get this done. And we had then a second further decision. So one is to electrify mobility and to electrify room heating. Electrify mobility will consume also during summer, so the excess electricity in summer could be reduced, but of course, due to the electrification of heat demand in winter, room heatings, import demand would even increase. And one we can say for a future mobility, which is similar for a future industry, for future technologies at all, is to support this scenario. So it's not only to drive electric or to heat with heat pumps. It's important to make such energy system manageable, which is not if we only replace gasoline cars by electric cars. We have to integrate these technologies into the energy system. And I would like now to show how this could look like. So we have, for example, seen that if we add 80 to 140 gigawatt hours of electricity storage capacity, we could make a full shift from day to night of electricity. So PV is only produced during day and not during night, but we are consuming electricity during night too. And if we can shift this day electricity also into the night, we could reduce we could integrate 5 terawatt hours in the summer and 5 terawatt hours in winter in addition. This means if we have this electricity storage capacity, we could use 10 terawatt hours more renewable electricity without producing one single kilowatt hour of renewable electricity in addition. So storage plays an important role, and especially passenger cars are running less than 1 hour per day and standing still during more than 23 hours. So they should be integrated as an energy storage device into the energy system. This would create a lot of additional benefits because then we can expand PV power without having a limitation in using it. If, for example, half of the Swiss passenger car fleet, assuming 3 million vehicles, are electric vehicles in such a concept, providing each 20 kilowatt hours of battery storage capacity, which is only a part, maybe 1/3 or 1/4 of the battery capacity, we could already cover nearly 50% of the energy storage demand we have in Switzerland to make a full day-night shift. So electric cars could not be or should not be only a vehicle with a different powertrain. They should become a part of the electricity system in future. But then still we have 7 terawatt hours of excess electricity. If this is not used, we also fear that the PV system is not developed to its full potential. So the use of excess electricity is important. It's clear less efficient than not using it, but if it is not used, we maybe will not install the corresponding PV systems. So for Switzerland, I think this is important. And here we see that hydrogen production could become a solution. Not because we have hydrogen cars on the road, but we need hydrogen applications, and maybe hydrogen cars or hydrogen trucks could be a solution in this, because we most probably need to produce hydrogen due to the excess of electricity we have in Switzerland. So to give you an impression, this 7 terawatt hours of excess electricity could be converted into hydrogen and feed 20,000 trucks. That's roughly 50% of the truck fleet we have in Switzerland. That's demanding because the infrastructure is not there, the production systems are not there, the costs are too high. But if we would achieve a net zero target, maybe we have to go in this direction too. This would allow to use excess electricity during summer, but of course will not supply the electricity demand in winter. And here we expect that we have to import sustainable energy in form of green molecules from outside. And this is the second thing I would now like to explain to you. Here I will skip these slides. The import of energy, as I explained before, in my opinion, will be mainly the import of molecules, green molecules. Of course, we will also exchange electricity with neighboring countries, but during winter, we need green energy, and this is maybe not available. Why, for example, we are looking to produce such molecules in the Sun Belt. This could be Middle East, this could be North Africa, Brazil, wherever. And since molecules can be transported, this is also an important option. We will also develop hydrogen transport infrastructures, but this will also take time. Maybe you, or I'm sure you know, this European hydrogen backbone, where several countries and several large industry partners are working on developing a piping system. This could become very interesting because in such a case, excess electricity in one country could be transformed into hydrogen and distributed to other countries or other parts of the own country where it could be consumed as hydrogen. But this takes time. I'm not sure whether this is already able to supply a large part of energy sectors by 2050, but at least on a longer term, this could become a relevant energy element in Europe. I will now explain how synthetic fuels are produced and why they are also important regarding negative CO2 emissions. So if we look how synthetic energy is produced, this looks simple in such a slide. It is a little bit more complex in reality, but for the understanding, we keep it simple. So we need, of course, renewable hydrogen. This should be produced by renewable energy. And for this, we need huge PV plants or huge wind parks. And it's clear in Switzerland we don't have the space to produce this amount of hydrogen, green hydrogen. So that's why we are looking for countries with deserts where we have twice the amount of solar radiation. So per square meter of photovoltaics, we can produce twice as electricity as in Switzerland. I will come to that point later. And of course, we need carbon dioxide. This hydrogen and carbon dioxide could then fed into a synthesis plant. This is a catalytic reactor where, for example, methane or synthetic diesel, gasoline, kerosene, or heating oil is produced, or instead of carbon dioxide, one could use nitrogen and then produce ammonia. And this could then be used using existing infrastructures for the distribution in the existing trade markets for the trading and existing hardware being vehicles, power plants, combined heat and power plants, things like that, to use it. And then, of course, these energy converters will emit CO2 again, but only the amount which was taken from the atmosphere or the biosphere before. And the same is true for the water. So this means synthetic or sustainable fuels are recycled carbons where the energy is supplied always on a renewable basis. Our nature is working like this over the photosynthesis, where also hydrogen is produced and hydrocarbons are produced. We would use this approach, nature selected, also for the technosphere. And this process is inefficient because we lose 30% of the energy for hydrogen production, and we lose again roughly 30% for the synthesis. So this means from electricity to fuel, we lose 50% of the energy. So we should not use electricity we can use directly for such a process. We should go directly to deserts where we have a lot of solar or wind potential and where we don't have a direct utilization of electricity. And these desert areas are huge. So this is a PhD thesis from 2020 from Germany, and this diagram shows the annual energy consumption with this small gray part, while the yellow big part is representing the annual solar irradiation to the Earth. So the sun is providing much more energy to the world we ever will use. And if we are concerned about energy supply in future, we should consider or compare the existing fossil and nuclear reserves, the known reserves, with the annual solar irradiation to the Earth, and we see that sun will provide much more than we will ever have as fossil energy. Of course, today we are relying very much on these fossil energies, but shifting to renewable energy, be it direct used as electricity or be it indirectly used as sustainable fuels, is a non-regret decision. We have to do it anyhow, and we can do it. It's enough energy. We don't have an energy problem on the Earth. We have a CO2 problem. And we are, for example, initiating a large-scale project in Oman. And if we compare Switzerland and Oman as example, we see that per square meter of land, we have twice the radiation, solar radiation. And this means we have also roughly twice the output of a PV square meter in Oman compared to Switzerland. So going to deserts compensates for the energy losses we have in the energy production. And now I would like to share how these sustainable fuels or synthetic fuels could also provide negative CO2 emissions. If we burn molecules, we have, let's say, two main effects. One is we provide heat. That's the wanted part of the equation. But we are also forming CO2 because we are burning carbon, and that's the unwanted part. And one idea is now to avoid this unwanted part by splitting or separating the carbon from synthetic methane. So if we produce, as I explained, methane by hydrogen and CO2 in a synthesis reactor, and we burn it, we will again produce CO2, but only the amount we took from the atmosphere before, but it is not negative. In the best case, it is CO2 neutral, but because this is linked with transportation, with plant installation, with technologies, it's maybe 70 to 90% CO2 reduction, but it's not negative. But if we separate the carbon from the hydrocarbon, then it could become CO2 negative because we take CO2 from the atmosphere, which is then not again released in form of CO2 to the atmosphere, but is stored in form of solid carbon. This solid carbon could then be used as a new material, for example, as carbon black substitute. This carbon black today is also produced from fossil energy in a very inefficient way. If we can produce it in this way, it would become more efficient and we can save a lot of CO2 emissions. Or we can store such carbon in concrete, and concrete is so a huge amount of produced material. This means even if we only add 5 or 7% carbon to the concrete, we could store a huge amount of carbon. And that's why we believe this could become an interesting part, not only for providing CO2 energy, CO2-free energy to heat, high temperature process heat in form of hydrogen, but this could become also interesting for a CO2 reduction by providing negative CO2 emissions, because I mentioned this at the beginning, we need also a huge amount of negative CO2 emissions. We also made life cycle assessments. This is the pre-study, and we have seen that we can reduce in such an approach more than 100% of emissions, meaning instead of producing 288 kilograms of CO2 for providing process heat by natural gas, 1 megawatt hour of process heat by natural gas, we could reduce this amount to minus 77 kilogram if the carbon is separated before. We are just now installing a demonstrate plant in an industrial environment in Switzerland. So we separate the carbon from the hydrocarbon from methane by applying a plasma chamber, and this plasma chamber is fed by microwave. In this plasma chamber, the methane is then split into hydrogen and carbon, and this is filtered out. The carbon is brought to a carbon process and the hydrogen to a high temperature process heat. The carbon is processed, granulated, and filled in big bags, where then it can be fed or transported to carbon black manufacturers. Now, summarizing everything, the energy supply system and especially the production profiles will change. Even if we are reducing the energy demand, we will become higher power levels, and we will become times where no or low power electricity is produced, and we will get times where we have too much electricity. We need to integrate these new technologies in a way that this energy system becomes manageable. Without integrating a lot of technologies, this is not manageable. And here, storage plays an important role, and the utilization of excess electricity plays a major role. I will go to the third part. We need also a lot of negative CO2 emissions, and combining the supply of renewable energy by sustainable molecules, green molecules, where the carbon can be separated and not released again as CO2, could become a cost-effective and easy to integrate solution, because no CO2 transport infrastructure is needed, but a solid material can be transported in a much easier way. So we need ideas how to avoid CO2 emissions, and how the carbon can maybe also become a new resource for construction materials, for carbon black production, for all the industry which is relying today on fossil carbon black, like the tire industry or rubber industry, things like that. I hope I could show you that future mobility, post-fossil mobility, is not only a question of powertrain, but is a question of integrating new powertrain technologies, be it electric powertrains, be it hydrogen powertrains, or be it sustainable fuel powertrains, into the renewable energy system. And of course, this may be different in private cars, where we see mainly electrification as a main pathway, or in heavy-duty trucks, in domestic trucks, maybe hydrogen, and in international transportation, but also ship and air transportation, we see synthetic fuels as main energy carrier. And this could be also in a similar way be different for power production in different countries. With this, I would like to thank you for the attention, and whenever you have questions, I would be happy to try to answer them.
Super, Christian Bach. I would like we're right on time, so usually we stop at 1/4 to the full hour, but we always also take questions. And now, please, if you have any question to Mr. Bach, please write it in the Q&A button. I do have a question. Now, if EMPA is, of course, a wonderful institute, as is ETH, and Switzerland is very proud of both. Do you see differences in international studies, kind of like you guys focus on what you have just outlined, and other institutions maybe across the globe have other focuses? Is there other areas that are out there, or do you say basically, and that's my gut feeling, that's it, this is the way forward?
Yes, we see differences within Switzerland, and we see also differences within Europe and the world. So I believe that we need all of the existing technologies in future, and they look different. They look different, or the distribution look different in different countries. For example, I see that the electricity grid plays a important role if one would like to electrify sectors. If the electricity grid is in a good shape and strong enough, electricity or electrifying is possible. If the grid is not available in a short term, we need other ideas. And yes, we have a project with industrial partner, especially with industrial partner, supplying different markets, different concepts, where we are also cooperating with countries outside Switzerland.
Okay, very good. So, but another question that always pops up when I hear that, because it is complicated and it's not an easy solution, and we will always have the difference in energy supply and demand, and then you need the storage solution, which is not easy. Now, still, if you maybe listen to a political debate, also here in Switzerland, lots of people would mostly from the green parties and the left parties, and also legislation to a certain extent, they are basically predicting the future that science, like you, has to build. Do you think there is a disconnect a little bit sometimes from in the political discussion to the reality of science?
Yes and no. Of course, it's good to have a clear guideline from policy. What are the targets? For example, is CO2 reduction a target or not? So this was clear, was maybe more clear a couple of years ago. Now this is questioned again. Also, it is clear that we need more technologies, and that's maybe sometimes oversimplification in the policy discussion. So it will, in my point of view, not be possible to electrify everything. Let's say, including only photovoltaics and wind parks, we need further technologies like hydrogen and synthetic energy carrier also. So I think it's always a little bit search for the right balance between the different technologies. Also search for the, let's say, domestic energy production. For Switzerland, electricity production is important, so that's why we can we should electrify as much as possible, but it will not be possible to fly with electricity. It's not possible to store electricity seasonally, so we need the green molecules too. And in this field, I see less discussions in the policy framework.
Yeah, my gut feeling is a bit that sometimes it's just it's also a little bit overpromise in a way, and not focusing on the reality of what it takes. And I know ETH is doing a lot of. We've had the discussion before. We had once an impulse session with the ETH Science Center, Energy Center, which was basically doing modeling, and the bottom line was more or less that Switzerland will never be able to, come up with enough energy if the electrification comes up, if we, say no to nuclear. Now, which brings me to, and this is of course something that, in politics you cannot say the word nuclear in certain parties, and we have a question about that in a way where Christoph is asking, what is the reason to resign from nuclear power in Switzerland? Have you considered new technology like nuclear compact fusion, which may be industrialized in the near future?
So I'm not a nuclear expert, so I have more private opinion. But if I, let's say, watch the discussion in Switzerland, Switzerland. This was clear, the event in Fukushima. And we have strong parties fighting against nuclear power. But I'm also aware that these new technologies are under discussion and will maybe revised. But that's a clear political discussion. Yes, I'm not too deep into this discussion, so I think there are other experts which I can tell here more than I can do.
Yeah, I'm definitely not an expert on this question. It seems, without knowing anything, that Switzerland has, we don't have a full stop that we are not allowed to do research on
Yeah.
nuclear, which is, I think, different to Germany. I'm not sure about that, but they are very adamant about not doing that. And I think in Switzerland, the tendency is a little bit that also politics would like to open the door again for research. But of course, it remains a political discussion. And the good thing in Switzerland, I'm pretty sure, if we will find a solution, and maybe we even consider building a new nuclear power plant in the future, which will be very expensive and very difficult, there will be a public vote on it. And then, so that's a little bit how it is in Switzerland. So the people will vote on things like that. Yeah, so now one last question maybe. I'm not sure, Mr. Voch. I have, my house, I got, got my solar panels, I got my, I think, heat, whatever wave pump, air heat pump. And I was trying to buy an electronic car, well, I'm an electronic car. And the question, what you were mentioning, that we are going to use actually our cars to be able to, to be used as a storage. I have heard that that is not really an option yet in Switzerland. So that we are still kind of like considering how we should do it and how we can do it and what the technology should be, etc., etc. Whilst I know that, for example, the Liberal Green Party of Switzerland is basically saying, well, that's a solution. That's the only way we're going to have, but the only thing we need is solar panel, we need our cars, and then everything will work. But when I try to put my car into kind of like only in my house as part of a battery into the system, I think I'm not allowed to. What is your understanding on the current status of using cars as a additional storage?
Yes, I would say that's possible from a technical point of view, but that's not the onlyest part of the game. So the electricity market is highly regulated, and you cannot only store and re-inject the electricity as you wish. And here I think the regulator has to provide recipes how this should be done, and it should also not, let's say, be in a way that it destroys the good ideas of storage. So if one can win too much with storage, this could also lead to misuse of storage capacities, only to have high capacity changes over a certain time. So this is not easy to make all the regulations, and if nothing is, let's say, paid, if there is no market value for storage, no one will do it. So it needs good regulations which are helping to develop the technology for serving the real questions, and not for only create new incomes for certain markets.
Okay, very interesting. So I will stop. I always have hundreds of questions that really interest me. I'm also wondering how something like that would work in the European Union. where you have maybe even a more, if you could think about this one, but maybe even more complex regulatory and legislative framework than Switzerland. And then even think of other countries and global and tech standards and everything. But I think it's great that, you know, there are solutions, and it's a bit the execution is the problem, and the financing, I guess, and motivation to actually apply those solutions. And so I thank you, Mr. Bach, and your teams for providing the first part of this, and also for having giving us insight into this very, very complex and important topic. Because if we don't have, you know, the energy mix, that the CO2 neutral energy mix to fuel our mobility needs, you know, we will not solve the climate issue, I think, as one part. So I think this sometimes is a little bit underestimated, and I also don't think people will reduce the mobility efforts. So I don't think that is a very serious proposition. So anyway, Mr. Bach, again, I babbled too much. Many thanks for your time, and also everybody here for attending our impulse session. Again, the next one will be more about having a look at you know, the changes that have affected Central Eastern Europe because of geopolitical dynamics, including the war. Completely different topic, but I hope you can join us as well. And so wish all of you very well-deserved break, and enjoy your lunch, and hope to see you soon again. Thank you.
Thank you very much.